Some standard results about differentiation. If we have a function y equals c, where c is a constant, then the differential of y, dy by dx, is equal to 0. Now we can see this because y equals c is a horizontal line that crosses the y-axis at c, so the gradient is always 0. dy by dx is the gradient, and so that's 0. If we have y equals ax, then dy by dx is equal to a. We can see this because y equals ax is a straight line with gradient a. We have seen that if y equals x squared, then the gradient function dy by dx is equal to 2x. And if y is equal to x cubed, then the gradient function dy by dx is equal to 3x squared. So this can be generalized as, if y equals x to the power n, then the differential dy by dx is equal to nx to the power n minus 1. So if we're differentiating a power of n, then we multiply by the power of n and reduce the power by 1. This can be proved quite easily if n is a positive integer, but it is true for all values of n. It's sometimes known as Wallace's result, and sometimes it's known as the power rule. Also, if we have y as a function of x, and dy by dx is equal to function dash x, then if y is equal to a function of x, then dy by dx is equal to a function dash of x. In other words, if we can differentiate a function, then if that function is multiplied by a constant, the resultant is just the constant times the differential of the function. So for example, if y is equal to 7x cubed, dy by dx is 7 times 3x squared, or dy by dx is equal to 3 times 7x squared. In other words, dy by dx is equal to 21x squared. In a case like this, we multiply the term by the power of x and reduce the power by 1. Also, if y is the sum of two functions, then to differentiate it, we just differentiate each term independently. So, if y is equal to function of x plus g of x, then the differential dy by dx is f differentiated plus g differentiated. This tells us that if we differentiate the sum or difference of different terms, we can differentiate each term individually. Note that if there are brackets in an expression, these should be expanded first before attempting to differentiate it. Let's look at an example. Differentiate y equals 4x cubed plus 5x squared minus 7x plus 6. Well, to solve this, starting with the original, we can differentiate, so dy by dx is 3 times 4x squared plus 2 times 5x to the power 1 minus 7. So that simplifies to dy by dx is 12x squared plus 10x minus 7. Looking at another example, sketch the graph of y equals x cubed minus 3x squared minus 2x plus 5 for values of x between minus 1 and 3. Well, to do this, we can plot the points going from minus 1 to 3. So if we make up a table, we can choose the values of x going from minus 1 to 3 and then calculate the values of y. And they are 3, 5, 1, minus 3, minus 1. We need to draw out some axes on some graph paper, and then we can mark the points and join with a smooth curve. In part 2, we're asked to find the gradient of the tangent at x equals 2. Well, starting with the curve y equals x cubed minus 3x squared minus 2x plus 5, we can differentiate, and that'll give us 3x squared minus 2 times 3x to the power 1 minus 2. So dy by dx simplifies to 3x squared minus 6x minus 2. Now that's the gradient function. So at x equals 2, the gradient is 3 times 2 squared minus 6 times 2 minus 2, which is equal to 12 minus 12 minus 2, and so the gradient is minus 2. In part 3, we're asked to find the equation of the tangent at x equals 2. Now to find the equation of the tangent, we can use the formula y minus y1 equals m into x minus x1, where x equals 2, y equals minus 3, and m is equal to minus 2. So y take away minus 3 equals minus 2 times x minus 2. Expanding the brackets, we've got y plus 3 equals minus 2x plus 4, or y equals minus 2x plus 1. And we can plot the line y equals minus 2x plus 1. In part 4 we have find where the tangent crosses the y-axis. Now the tangent crosses the y-axis where x equals 0. So putting x equals 0 in the equation y equals minus 2x plus 1, we get y equals 0 plus 1. In other words, the tangent crosses the y-axis at y equals 1. In example 3, we're asked to sketch the graph of y equals 3x plus 3 minus x squared for values of x lying between minus 1 and 4. Well, to sketch the graph, we really need to draw out a table. So choosing values of x between minus 1 and 4, we've got the values of y are minus 1, 3, 5, 5, 3, minus 1. We can plot those points on a grid and draw a smooth curve. Now in part 2 we're asked to find the gradient when x is equal to 3. Now we've got y equals 3x plus 3 minus x squared. So if we differentiate, we get dy by dx equals 3 minus 2x. So at x equals 3, the gradient is 3 minus 2 times 3, which is 3 minus 6, or minus 3. So the gradient is equal to minus 3. In part 3, we have to find the equation of the normal at x equals 3. Now if the gradient of the tangent is minus 3 and the normal is perpendicular to that, that means to find the gradient of the normal we change the sign and take the inverse. So the gradient of the normal is plus 1/3. To get the equation of the line, we can use y minus y1 equals m into x minus x1. Now we have y1 is equal to 3, we have x1 is equal to 3, and m is equal to 1/3. So that gives us y minus 3 is equal to 1/3 into x minus 3. Well, if we multiply all the way through by 3, we get 3y minus 9 equals x minus 3, or 3y equals x plus 6. And that's the equation of the normal. We can now draw in the normal on the graph. Now in part 4, we want to find the other point where the normal intersects the graph. And to do this, we have to solve the two equations, 3y equals x plus 6, and y equals 3x plus 3 minus x squared. Now, multiplying by 3, the second equation can be written as 3y equals 9x plus 9 minus 3x squared. So equating the 3y in each equation gives us x plus 6 equals 9x plus 9 minus 3x squared, which simplifies to 3x squared minus 8x minus 3 equals 0. Now that factorises as x minus 3 into 3x plus 1 equals 0. So either the first or the second bracket must be 0, and so x is equal to 3, or x is equal to minus a third. The case x equals 3 is our original point, and we want the other point. Now if x is minus a third, then 3y is equal to minus a third plus 6, so y is equal to 2 minus a ninth, which is 1 8/9. So the other intersection is minus a third, 1 8/9.